So, good evening. My name is Jason, and I'll be talking about biodiagnostics using cantilevers. So, if you're sick today, you go to the doctor, and he'll probably stick you in the arm with a needle and take a nice blood test to confirm whatever he thinks is wrong with you. We all know this isn't very pleasant. It kind of hurts a bit, and he ends up taking a lot of blood. It also costs some money, takes some time to do, and you need someone really well educated in order to be able to just diagnose the disease and analyze your blood sample. So this isn't really practical, and in the future we'd like to move towards something like this, where we take a small sample of your blood. It's cheap, it's so easy a monkey could do it, and basically the aim of my PhD then is how we go from the situation on the left to the situation on the right. So I work as part of an interdisciplinary team where we try build a device to do this. So I work with a bunch of chemists. Something will appear down here now, I'm a little ahead of time. So chemists, engineers, microbiologists, and we even have an astrophysicist in our group. And we'll do this then using cantilevers. So what is a cantilever? It's just like the diving board that you see at your swimming pool. It's a beam of material that's free at one end and clamped at the other, and it's then free to vibrate. And we're interested in really small things inside a blood sample, so we use really, really small cantilevers. This here is an image of the chip that we use. So it's 2.5 millimeters wide and contains 8 cantilevers, which means we can do 8 tests at once, and this brings the cost of the test down. Each cantilever is only 1 micron thick, so that's 1/1,000,000th of a meter. And the device then that I've developed works a bit like this. So we can see here we have the cantilevers, and I'm shaking them, and then I shine a laser beam off the surface, and I look at the reflection of the laser beam, and this tells me something about the properties of the cantilever. So after I've shined the laser on the surface, I get a graph which looks like this, and these peaks then basically tell me about the properties of the cantilever, and most importantly how much mass is on the surface or how much stuff has stuck to the cantilever during the experiment. So it's this property then that we'll use to analyze a blood sample. So if you have your blood sample here and you're interested in finding out whether or not these blue antigens, which are basically disease molecules, are in your blood sample, they're probably surrounded by a lot of other stuff. So I take a nanoparticle, basically a small sphere, coated with something called an antibody, which is specific for these blue ones, and it's like a locking key, so it only picks up the blue ones. Then, because it's magnetic, I can stick a magnet underneath, pull the nanoparticle down to the bottom, and remove all the yucky blood and replace it with something nice. Then I change the surface of my cantilever to be, again, specific for this disease, and then I shine my laser beam off the surface, shake the cantilever, see what the initial properties of the system are. Then I take my nice nanoparticles from my nice new solution, flow them across the surface of the chip, and then some of them will stick. And you can see here then in this graph that you get a noticeable difference between the original state and the new state. And this tells me then whether or not you have this disease molecule present in your blood. And that's the end of my talk. Thanks very much.